In this video, we'll be going over calculating the HCF of a set of numbers. So LCM and HCF are both topics that come up in the 11 plus and in GCSE as well. So it come up in the few easy questions that start off the GCSE. And so if you get an understanding of this, you can get really easy marks throughout maths from the 11 plus to the GCSE level. Let's start off with our first question. So we have to find the HCF of each group of numbers. The HCF, we know that the HCF is the highest common factor. So what we're going to do is we're going to split the two numbers that we have here, 156 and 52, into their corresponding prime factors. So let's start off with 156. So there are different methods that you can do this through. We're not going to be using the tree method, but we are going to be using something that has the same idea of it. So we know that 156 is an even number, so straight away we can take 2 as one of the prime factors. 156 divided by 2 gives us 78. 78 is also an even number, so we can take 2 as the prime factor again, another 2, so 78 divided by 2 is 39. Now 39 here is not an even number, but we can easily see that it is a multiple of 3. So we can take 3 as another prime factor. 39 divided by 3 is 13. And we know that 13 is a prime number and it has no other factors other than 1 and itself. So we can write 156 in the product of its primes as 156 is equal to 2 times 2 times 3 times 13. And in a similar way, we're going to do it to 52. So let's start off with 52. 52 is an even number, so we can remove 2 from it as one of its prime factors. 52 divided by 2 gives us 26. 26 is also an even number, so we're once again going to take 2 as another prime factor. 26 divided by 2 is 13, and like before, 13 is also a prime number, and so it can't be split further down. So we have 52 as a product of its primes as 2 times 2 times 13. What we're going to do now is we're going to compare each of the prime number multiplications. And any numbers that are shared, we're going to circle them together. So we have the first two 2's that are shared between both. Next we have the second two 2's. Now we can see that 156 has a 3 in it, that 52 does not. So we're going to avoid this 3, and we're left with 2 13s that we can also circle. So these are all the prime factors that are shared. So with only one number, we're going to multiply those together. So we have a 2, another 2, and 13. And multiplying these numbers together gives us our highest common factor. But we can already see that 52 is made up of 2 times 2 times 13. So we can have this as 52. So the highest common factor of both of these numbers, 156 and 52, is 52. Let's go on to our next numbers. So we now have 3 numbers, 336, 96, and 144. So first off, we're going to divide 336 into its prime factors. So we can see that 336 is an even number, so it's a multiple of 2. So we can divide it by 2 and we get 168 as our remaining number. 168 is also a multiple of 2, so we can divide it by 2 again, and we can get 84. 84 is an even number. We'll remove another 2, and we're left with 42. And once again, 42 is also an even number, so we can remove another 2, and we're left with 21. Now we know that 21 is an odd number, but it is not a prime number, so we can keep dividing. So we know that 21 is a multiple of 3, so if we divide it by 3, we get a remainder of 7. 7 is a prime number, so we can stop here, and we have our 336 as a product of its primes as 4 2's multiplied together, and we have another 3 and a 7 times 3 times 7. Now we'll do the same for 96. 96 is a multiple of 2, so we can divide it by 2 and we'll get 48. 48 divided by 2, because it's even, gives us 24. 24 is also even. If we divide it by 2, we get 12. 12 is even, so if we divide it by 2, we get 6. 6 is even, so if we divide it by 2, we'll get 3. 3 is prime, so we don't have to go any further, and we can write 96 as a product of its primes as 5 2's, 2 times 2 times 2 times 2 times 2, and times 3 at the end. Now we'll go on to 144. 144 is an even number, so we can divide it by 2, and we're left with 72. 72 is even, so we can divide it by 2, and we're left with 36. 36 is even, so we can divide it by 2, and it gives us 18. 18 is even, so we can divide it by 2, and that gives us 9. And we now know that 9 is a multiple of 3, so we can now divide this by 3, and we're left with 3 remaining. 3 is a prime, so we're going to stop there, and we're going to write out 144 as a product of its primes. So this is 4 2's multiplied together, and then we'll multiply 2 3's. Now we're going to do the same method as before, and we're going to circle the numbers that are shared. So we have a first set of 2's that we can circle, our second set as well. There's a third set. And there's a fourth set. But we can also see that there's one extra 2 remaining on 96. But the other 2 numbers don't have any more 2's left, so we're going to ignore it. So that 2 we will ignore, but now we have a set of 3's, so we're going to circle those. And now we're left with 7 for 336, so we can get rid of that because none of the other numbers have it, and we have an extra 3 in 144, so we can remove that. Now, with the numbers that we have, we can multiply them together. So we have 4 sets of 2, so we have 4 2's. We have a set of 3, so we multiply that by 3. And so we can simplify this multiplication down into 4 times 4 times 3. We know that 4 times 3 is 12, and 4 times 12 is 48. So our highest common factor for this is 48. Now we have 4 numbers, 66, 30, 54, and 12. So just like we did for the previous questions, we're going to do the same thing here. So 66, we're going to divide it by 2 because it's even. We're left with 33. We know that 33 is a multiple of 3, so we're going to divide it by 3 and we're left with 11. 11 is a prime number, so we're going to stop here and we can write out 66 as a product of its primes. This is 2 times 3 times 11. Next we'll move on to 30. So 30 is an even number. We can divide it by 2 and this gives us 15. 15 here is easy to see, it's a multiple of 5. So we can divide this by 5 and we're left with 3. Now 3 is a prime number, so we can stop here and we can write out 30 as a product of its primes. However, what we're going to do here is we're going to write it out in the order of increasing size. So we're going to do 2 times 3 times 5. Even though in our calculation we got 2, 5 and 3 in that order, we're going to write it out like this so it's easier to see the numbers that are shared. Next we'll move on to 54. 54 is a multiple of 2, so we can divide that by 2 and we're left with 27. 27 is a multiple of 3, so we can divide that by 3 and we're left with 9. 9 is a multiple of 3, and if we divide it we're left with 3. 3 is prime, so we're going to stop here. And we're going to write 54 as 2 times 3 times 3 times 3. And finally we have 12. So 12 is an even number, so we can divide it by 2, which gives us 6. 6 is even, so we can divide it by 2 and we're left with 3. 3 is prime, so we can stop there and we can write 12 as 2 times 2 times 3. Now as before, we're going to find out pairs of numbers that are there. So the different sections. So we can start off, we all have 2, so we can circle all of those. Now we can see from 66, 30, 54 and 12 that 3 is shared between all of those. So we're going to circle all of our 3's here, going down. But now what we can see is the numbers that remain aren't shared between all of those, so we can cross all of those out. So 11, 5, 3, 3 and 2. Now we're left with 2 times 3. And if we multiply them together, we have 6. And 6 here is our highest common factor.
As always, thank you for watching and make sure you subscribe so you don't miss out on any new content.